Okay, so Juan is studying exponential growth bacteria cultures. Each is carefully controlled to maintain a specific growth rate. Okay, I'm glad you know. Copy and complete the table to find the number of bacteria in each culture. Now I'm going to do this with you so you can see what numbers go in there. What would you do with that 10,000? What would you multiply it by for the 8% growth rate? 1 point what? 08. Okay. Now, what exponent would you use for 1 day? 1, right? Okay. That's important because when I go to the next one down and I change the growth rate to 4%, what exponent am I going to use? 2 days. Okay. So they cut the growth rate in half, but they doubled the amount of days. So let's just see what happens when I do this. Come on. And where are you at? Okay, so the exponent is a 1, 10,800. When I cut the rate down to 4%, but then I change it to 2 days, look what I get, 10,816. So you're thinking, okay, wait a sec, you cut it down to 4% and double the days. Wouldn't that give me the same amount? Okay, so what happens if I cut it in half again? Now I'm down to 2%, but I have 4 days. Look what's happening, folks. Stop tapping it, please. 10,824.3216. It's getting bigger. I'm cutting that rate down, and now I'm raising it to the 8th power, and it's still getting bigger. But now, what do you notice about the change between them? Obviously, there's 16 between the first two, right? How much is between the next two? A little over 8. How much is between the next two after that? Like around 4, right? A little over 4. What do you think's going to happen when I raise this? So we've gone from 8% to 4% to 2% to 1% to what? 0.5%. And I'm going to do it for 16 days. The difference between them is a little over 2. But each time I'm doing that, I still get a bigger number. Now, instead of thinking of this as bacteria, what if this was your money? It's going up. I can take a lesser percentage as long as the time is longer. So now you know it. I hope you filled in this table as we went through it. And we pretty much answered the part B as well. Example 1. In 2015, the population of a small town was 8,000. The population is increasing at a rate of 2.5% per year. Rewrite an exponential growth function to model this situation. Okay, so we've got y equals something times something. They're using t. We can use x. I don't care. It doesn't matter to me whether we use t or x. What should I put in the first blank for the starting amount of the population? What would you like? So what was that? 8. We could use 8. If you wanted to use 8,000, you could use 8,000. Either one of those is acceptable. Now, growing at a rate of 2.5%. Remember, I talked to you about how every growth factor in the universe starts out at 100%. In this case, we're going up by 2.5%. What percent is that? 102.5%. Now, please convert that to a B value. Please convert the 102.5% into a B value. What would it be? 1.025. Thank you very much. That's what I need to be using in those parentheses for B. Whether I use this one or this one, 1.025, it does not matter. Now, T represents the number of years after 2015. After 2015. Yeah, next time just yell at me when I'm frozen. What does 12T over 12 represent? What does it equal? That's just one what? One T. So they didn't do anything magical with that T. All they did was they rewrote it as 12 over 12 times T. Now look what they did with the exponent. Do you see how they separated it? They took the denominator part into the inside. And they left the numerator part on the outside. And then they calculated this. 1.025 to the 1/12th power. And when they typed that into their calculator or Desmos, they got 1.00206. What the heck kind of growth rate is that? Remember, everything starts out at 100%? And in this case, it went up. What percent is that? Convert that back to a percent. What is that number as a percentage? 100.206. What percent is it increasing every month? 0.206%. So the monthly increase is 0.206% per month. Now you have a formula that you can use with months, not years. So if they decide to do that and ask you about months, you will have to do a little bit of work to convert that B value. Basically, you're just going to take your B value and raise it to the 1/12th power. Here's an example of a compound interest formula, which is also an exponential formula. Now, I know you look at something like this and you're like, well, how does that and this, how are these things similar? Well, those two things are the same. These two things are the same. The part that may be a little bit unusual for you is that B is a little bit weird. B is that entire thing that I just circled in blue. So this is an exponential function. It just looks a little bit different. Looks like there's more pieces. So what are those individual pieces? Well, P is the principal amount invested. That's how much you started with, right? Just like A, that's the starting amount. R is the interest rate. Now, look what it says there, written as a decimal. If you've got 6%, don't you dare put 6 in there for R. You have to convert it. You're going to be looking for things like 0.06. If you truly put 6 in there for R, your number will be huge. Because you're going to be multiplying your money by 6 times every year, which would be fantastic, right? I mean, if your money multiplied by 6 every year, holy cow. Soon I'd be buying my own private island. You know? I mean, if my money multiplied by 6 every year, that'd be awesome. Okay. You might have to be doing some illegal things for that to be the case. Oh, yeah. Yeah. I mean, if you're extremely good at sports betting or know the future, yes. 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 Or you come from a rich family. Okay. Now, N is the number of times compounded in a year. How many times are you getting interest every single year? That we're going to be using different terms. Terms like annually. Is it annually got 2 N's? I hate double consonants. Okay, annually means an N value of 1. What do you think quarterly means? What do you think the N value is for quarterly? 4 times a year. Yep. How about monthly? 12. How about daily? 365. Those are the most common terms. Now, I don't know if we're going to run into any others. Obviously, A is the amount of money that you get after everything is said and done. A is the amount that you get after everything is done. So P is what you start with, and then you get interest for so many years, and then you get your money invested out of it. Now, okay, so example 2. Now that we've explained all of the parts of the formula, A equals P times 1 plus R over N to the NT power. Tamara invests $5,000. Where does that go in my formula? That is P, the principal. That's the starting amount. A, we do not know. In an account that pays 4%, what should go on top of that fraction? Please don't tell me 4. 0.04. Right. You move the decimal over. You need the decimal version of 4%. Now they start off, it does say that we've got 3 years, so we know that number. but they want to start off with annual interest. The compounding factor is annual. So, what does the word annual mean? How many times a year? Once. So, you're starting off by plugging in a 1. Take your calculator or your Desmos Scientific and figure out what that number is. Go. 5,624.32. Now, I want you to notice this term semi that they have put in front of the word. Have you ever seen a commercial for a furniture store that does a semi-annual sale? How many times a year are they doing the sale? They do it twice a year, right? Every 6 months they're doing this sale. So when they put semi in front of it, what does it do to the word annual? Annual means 1. If I put semi in front of it, what does it do to it? It doubles it. So that's why you see in their formula that they changed it to 2. So if they put semi in front of something, you should understand that that term doubles it. It doubles the end value. Now, there is another term. For instance, I receive bi-monthly paychecks. Bi-monthly paychecks. Now, what does that mean? Every 2 weeks, right? Okay, so I'm getting, every 2 weeks I'm getting paychecks. So I get 2. Yeah, you're right. I would be getting semi-monthly. You're right.
Twice.
I think they used the term wrong.
Twice.
Right.
Because we did the first and the fifth.
Correct. But I think they used the wrong term. They should be using semi. Because you're right. Because that would be every other. Right. So I think I'm getting semi-monthly checks by definition. But I think they actually try to use the wrong term.
This said bi-monthly means twice a month. Oh, or every 2 months. So it can be 1.
That's weird. I don't know why they would use the term both ways. That makes 0 sense. Okay, find these other ones. Quarterly, semi-annually, quarterly, and monthly. Get them in your table here. Double check that you're getting the same numbers. Okay? Anybody need those numbers any longer? Okay, just double check that you can type on a calculator and get the same results. Yeah?
And so then I wrote down wrong.
Yeah, bummer. Mm-hmm. Next page. Consider an investment of $1 in an account that pays 100%. 100% interest for 1 year. Okay, now this is completely unrealistic, right? Getting 100%. So what's going to happen on the very first one? What is 1 plus 1 raised to the first power? You double your money, right? That's the easy one. Okay? So get your calculator ready. We're going to be changing. Yeah, I see it. I see it. 1 plus 1 over 10 raised to the 10th power. When we get back, we're going to be filling this chart in, folks. What, Malat? As much as I can. I can't get everything done because I've got too many other things to do, but
It has to grade your assignments.
I wanna learn. What did you notice when you did this? Were you getting larger numbers each time? Did you know there was a guy by the name of Leonard Euler who did this? He said, let's suppose that we started with $1 and we were investing it at 100% interest rate, and we continued to increase the compounding factor. Now, only a super nerd is going to do this, right? I mean, nobody's going to mess around with this unless they're just really into math. But this guy did this, and he noticed that as he continued to raise this, the number got higher and higher and higher and closer, but it's slowing down. Do you see how it's getting bigger, but it is slowing down? That's because it's getting closer and closer and closer and closer and closer to a single number, but it's never reaching that value. What does that sound like to you? A horizontal asymptote. That's exactly what you're thinking of, or should be thinking of. So they decided they were going to name this after him. Okay? His last name was spelled like this: Euler. Leonard Euler. So they named it after him. And it's programmed into every single scientific calculator. They named it E. Now, E, which is programmed into your scientific calculator, is this massively long number, folks, that never stops and never repeats. It's an irrational value. Obviously, your calculator didn't go that far when you were typing in these things. Remember the formula we were dealing with? P times 1 plus R over N to the NT power? Well, what happens if the N value is raised to a very large number? Well, guess what happens to this thing that I just highlighted in that box? It becomes e to the R power. And then this formula looks like this formula, the PERT formula. Yes, folks, it is very pretty. Under what circumstance would you use this formula and not the other one? You are looking for a phrase like this: continuously compounded. As soon as you see continuously compounded, you will immediately switch to the PERT formula, not the other compound interest formula. So you need to look in the problem that you're working on. Does it use one of the words like annually or monthly or quarterly or daily? Well, then you're using the first formula. But as soon as you see the phrase compounded continuously or continuously compounded, something like that, you are immediately going to be switching to this formula. Oops, sorry. Regina invests $12,600 in an account that earns 3.2% annual interest, compounded continuously. There's our phrase. So now we know we're using the PERT formula. What's the principal? What's the starting amount? What goes in the first part of the equation? We already know that A is over there. We're trying to figure that out. How much are we starting with? 12,600, right? E, my exponent. Now I know there's a 12 years involved in it, but what's the interest rate?
3.2.
Are we going to put 3.2? No, we're not. What are we going to put for this? 0.032. You put 3.2, you're going to get a very unrealistically large number. Use your calculator right now. If you are using Desmos Scientific, you literally need to type the letter E on the keyboard. It automatically knows that that is the same number. Go. We need to find this value. We will create two equations with these coordinates. So we have 2015 and 1,000 emails, and 2016, 1,400 emails. Now, I'm going to make a suggestion to you that you really need to pay attention to. Start with the highest X. Start with the highest X value. I see we've got two coordinates here, but I'm recommending to everyone in this room that you start with the highest X value. It will save you trouble in the future if you listen to me on this. So what's the highest X value? 2016. So my first equation, I'm going to take the coordinate and plug it in. Obviously, I'm replacing the X and the Y. So 1,400 equals AB to the 2016 power. Underneath that, 1,000 equals AB to the 2015 power. Now, if you know that we are doing division, in order to get these two equations together, we are going to do division. This is a very similar idea to what we did with elimination back in the first semester. What is 1,400 divided by 1,000? 1,400 divided by 1,000. It's not 14, but you're getting closer. 1.4? Does anything cancel out on the right-hand side? The A's are gone, folks. I'm dividing like bases with the B's. What are we allowed to do with the exponents? What are we supposed to do with these exponents? Subtract them. Don't divide them, subtract them. That is b to the first. Now, is that equation already solved for b?
Yes. That one.
Well, that's kind of cool. Now I know what b is. It's 1.4. What if, when we did this process, we got b squared? We would have to take the square root of both sides. So, what if it was b cubed? You have to take the cube root of both sides. So it's not always completely simplified like this. But this is nice, right? Now, imagine that you accidentally flip this over because you started with the other one. Then you would end up with b to the negative first. A lot of you panic when you see a negative exponent. You don't know what to do with it. And then bad things happen because your math goes haywire. So I always suggest you start with the highest x value, and then you're never going to have that problem. Okay. So now we know what the b value is. Do we have any equations that we could plug it back into and figure out what a is? We could use either one of them, right? Do you have a preference? First one? Okay. We'll use the first one. 1400 equals a times 1.4 to the 2016 power. You need to solve that for a right now. Go. Oh, I don't know why that's frozen. Get it solved for a. Come on, stop doing that. Thank you. Whoa, it didn't like that, did it? Did your calculator have a difficult time like mine did? Oh, you packed up. Wow. I don't even know if Desmos will do it. Let's just see. What do you have to do? What do you have to do with this number, whatever it is? How do you get this number to move to the other side? I haven't heard a good answer. What do you think? No, we're not square rooting anything. What do we do with this number once we find it? We divide it to the other side because that's the opposite of multiplication. But my calculator was having a hard time with 1.4 to the 2016 power. I'm going to see if this has the same issue. Well, it's a little bit large, but Desmos does handle it. We'll see if we can figure out a different way to handle this problem on Monday. We need to figure out something else that'll work because this ain't doing it. Our problem is with our exponent and how high it is. So what we're going to do is we're going to change this from 2015 to 0. Now, if we change 2015 into 0, what would that change 2016 into? 1. So we're really dealing with the coordinate 1, 1,000. 0, 1,000. Can't even listen to myself. And 1 comma 1400. Okay, so that's obviously going to change a little bit here, right? Do we still start with the high? Which one do we start with again? I tried to tell you. Highest what? X value. That's what I wrote on screen. Highest X value. So 1400 equals AB to the first. And in the bottom equation, 1000 equals AB to the 0. Do the A's still cancel out? Yes, they do. Do I still get B to the first when I subtract the exponents? 1 minus 0. Yeah. So we still know that B is equal to 1.4. And may I remind you or ask you again, what did we talk about if we do the subtraction and we end up with B squared? How do we get rid of a square? Square root. What if it was B to the third? How would we get rid of a third power? Cube root. But we didn't have to do that because it was B to the first. Stay with me. Now, do we have an equation we could plug it back into and figure out what A is? Sure we do. We got 2 of them. Anybody got a preference? Top one? Okay. So 1400 equals A times 1.4 to the first. How do we get A solved for? What should we divide both sides by? 1.4. So what's A? You need a calculator if you don't know. $1,400 divided by 1.4. I heard you say louder. 1,000. What if we had used the other equation? What is B to the 0? B to the 0 is 1. Oh, man, it would have told me that A was 1,000. Doesn't matter, folks. You can plug it back into whichever one you choose. I don't care which one you plug it back into. You're trying to find out what A is. Now, what was the question here? Write an exponential model. Okay, y equals 1,000 times 1.4 to the x power. That's what they just asked me to do. Write the exponential model, folks. Now, I just noticed something. There's a slight problem with what I did. But I'm going to make an adjustment here, folks. We did it since the year 2015. Now, if they really wanted me to start with 2009, okay, then I probably would have, that would have changed my X. Let's see, I would have had, my coordinates would have been 6, 1,000 and 7, 1,400. We still would have worked through everything. We still would have found out the A and the B value. But all it does is change what you call X. In ours, yep. What? I don't believe you. Okay. Growth factor, well, we already figured out the growth factor, 1.4. We already figured the answer to that part out too. Use the value of B in one of the data points to find A. We just did that. I don't need to do that again. They might ask me another question like, how many emails in the year 2027? Well, you tell me, if 2015 is where it's starting from, and they want me to go to 2027, what is the X value that goes with that? What X should I be using for 2027? How many years after 2015 is 2027? 12 years. So I would literally need to go to my equation and put in 12. Find me the value. Something. Yes, handheld calculator. Nope, nobody in this room knows. Nicely done. You're not gonna know that off the top of your head. You need technology of some sort. So use the technology you'll be using on the test. Nicely done. We get scientific only. Oh, not graph or start. Let me pause this. Yeah, like 56,000. 694, something like that. It doesn't need to be perfect. Okay. But there will be questions like that where they ask us to use our model to make predictions.
I got questions on the try question thing, and that's what it asked me to do for try number 6, I think.
Okay.
I don't know.
Example 6. Randy's making soup. The soup reaches the boiling point and then, as shown by the data, begins to cool off. Is it cooling off in a linear pattern? Is it dropping the same number of degrees every single minute? No, it's not. Folks, it's going to be doing something like this. What is it getting closer and closer and closer to? When you have something that you pull out of the microwave and you just let it sit out on a counter, what is it trying to get closer to? Room temperature, right? It's not going to go below the room temperature of what's the air that's around it unless you throw that doggone thing in the fridge or freezer. Talk about it when we get back. Okay, so it will be going down, getting closer and closer to room temperature, but obviously not at the same rate all the time. This is an exponential decay function. So, what kind of coordinates? Explain why the temperature might... We already did that. Find an exponential model. That's part B here. Use your model to determine when Randy should serve the soup. All right, we'll figure that out here. Do we have any coordinates we can use? Can we make coordinates out of what we see right here? All right. So how about 0 to 12? Pick something else. Kiefer, pick one. Okay, so 2, 185. All right. So let's see here. Always start with which one?
The higher.
One with the highest exponent. Okay. So 185 equals AB to the second. And 212 equals AB to the 0. And because these are based upon multiplication, what are we allowed to do with the two equations? Are we going to add them? What did we do before? These are based on multiplication. What's the opposite of multiplication? Division. So we're dividing them. Yes, you'll need your handy dandy calculator because nobody knows 185 over 212. It's not like it's going to be a nice number. All right, 185 over 212. Point what? 873. Good enough? Anything cancel on the right side? The A's. Giving me B to the what? To the second. All right, so how am I going to find B? Square root. Oops. Might as well just take the square root of what I got in my calculator so that I can get the most accurate value. So now we know that B is approximately equal to 0.934. Before we continue, just a quick question. Remember, I've drawn these pictures for you before? And I've told you that you start at 100%. In this case, what percent are we at now? How can you convert 0.934 into a percentage? 93.4%. So my question to you right now, what percent are we losing? What percent are we losing? 6.6%? Is that right? Yes, no? Yep. That was funny. I do appreciate that. Okay. Yeah. It's a loss of 6.6%. I know they didn't ask me that, but I figured we could figure it out anyway. Write your equation. Now, everybody knows that 0.934 goes in here. I'm curious what you're going to put in the first blank. Go. Okay, what'd you put in there for that blank? 212. You plugged the value back in, but you saw from the bottom equation that 212 was the value of A. So here's the graph of what you and I just created. Why is that completely unrealistic? What is wrong? Something you told me earlier. What? It goes below room temp. It thinks this equation is acting like we're going all the way to 0. So, what if we just shifted the whole graph up to like 68 degrees? Now what's wrong with my picture? Now I'm saying that the starting amount was 280 degrees. Okay, so I'm confused. What the heck? I know it's supposed to bottom out at around room temp, but how do I get this thing to... Well, let's take a look at what they suggested here. What was their strategy in step number 1? What should we have done from the beginning which would have helped us? Subtract 68 from the temperatures. That would have given us the correct shape, and then we could have done this little plus 68 at the end and been okay. Okay. So as you can see, they went through the process of what we did, but these numbers were different. They actually cheated a little bit, and they used the regression part of the calculator to do it for them instead of just using a couple data points. I don't think that's the strategy we're going to use, but I will verify that with someone else before we go on, because that's way too easy. So if we had subtracted 68, let's just redo that quickly here. 185 minus 68 would have given us 117. 212 minus 68 would have given us 144. And so if we go through this, 117 divided by 144, and take the square root like we had before, I actually got a slightly different value. 0.901. Oops, sorry. So this was 0.8125, and then we would take a square root. Come. 0.901. We can see here that 144 is our value, so we'd have 144 times 0.901. Oops. To the x power, and then we have that plus 68 at the end. I know their equation is slightly different, and that's because they used multiple points and a much fancier way to get their equation, not using the values like we did. And I will get back to you on that other method if we need to. I don't think we really do, but we'll find out.